Okay, moving on to rotations. So doing this online, again, guys, is going to be one of these things where you're really going to have to write stuff down. You're going to have to copy things off of Canvas because we can teach rotations. I was just turning something using a formula. However, I kind of hate formulas because it's something you have to memorize. If you can just understand how to do something without a formula, then we'd prefer that. So when we do rotations, on your notes for 6.3, right here at the bottom, this is what we're going to be focusing on. The steps for plotting rotations. Now, this sounds more complicated than you're like, why can't you just give me a formula? This is 6 steps. But it makes sense, and so it's going to be a lot easier to remember. So, again, a rotation takes a shape and turns it. Now, specifically, it turns it around a center of rotation. If any of you guys ever played tetherball as a kid, I went to Roadrunner. Anyone else went to Roadrunner Elementary? They had tetherballs. And it's a pole with a rope and a ball attached to it, right? And then you hit the ball and it wraps around the pole. The pole is the center of rotation because as that ball swings around, it's going around the pole. Yeah. So that's what you can see here. This is the center of rotation, and this shape is going around this way. Another way of thinking about it is like the moon, right? The moon goes around us. We are the center of its rotation, just as the sun is the center of our rotation. Yeah. So understand that that's what we're talking about versus we know the earth also spins on itself. Typically what we're talking about in this class is going to be a rotation around a point versus spinning like this in one spot. So a couple things we have to understand. You are going to be told a certain number of degrees for the rotation. So what we have to understand here is how we use that. 360 degrees, you guys can add this here. Do you guys know how much of a turn? You should know this. How much of a turn 360 degrees is? This is a full turn. Add that to your notes. So that would be like me taking my notes and just going do. I end up right back where I started, right? That's a 360 degree turn. So moving downward from here, 180. Hopefully you can see kind of the difference between those two. 180 is a half turn. So if I were to take my paper, a half turn would just be 1, right? That's a 180 degree turn because that's half of a full turn. The last degree of rotation that we will be working with is a 90 degree. So once again, we're kind of working our way down. If we had a full turn, a half turn, the last thing we have is a quarter turn. There you go. So a quarter turn would be like taking your paper and going 1. That's just a quarter, right? 1/4. If I did 4 of these, 1, 2, 3, 4. Hey, look, I'm back to where I started because each of those was a quarter of a turn. So these are going to be the, well, not this one actually, because 360 does nothing. Yeah, 360 gets back to where you started. These are really the 2 that we're going to be working with mostly. We'll talk about there's one other one. The other thing we have to know is the difference between clockwise and counterclockwise. So if you could write one more little thing here. Clockwise. If you've never heard what clockwise is before, clockwise means it follows a clock, like the one I have in my classroom, right? Obviously, we have my little clock here down in the bottom, but that's not what we're talking about. We're talking about a circle clock and how it goes, right? It goes 1, 2, 3, 4, 5, 6, 7. Yeah, so clockwise follows a clock that's actually to the right. Counterclockwise, excuse my terrible handwriting here, I'm using my mouse as always. So counterclockwise means the opposite direction of a clock, which is to the left. So these are the things we have to understand in order to do these problems, but they're actually pretty simple problems from there. So we're actually going to do example 2 first to talk about the difference between clockwise and counterclockwise. And then we'll try just number 1, and then we'll come back in class and do the rest. So clockwise or counterclockwise. Now, to start with, in order to know if we're rotating clockwise or counterclockwise, we have to know what's my original figure and what's my new figure. Looking at the labels on these, is it the red shape or the blue shape? Which one is my new figure? Red shape or blue shape? Which one is my new figure? What do you think? The red shape is the new one. We would call this the image, right? Because it's the primes. Yeah, primes tell us that's the new shape. So this was the old shape. And again, we call that the pre-image, right? So this is the image. We'd call this the pre-image. So what this means is we started here and ended up here. So this is the direction of my rotation. I'm going from my blue shape over to my red shape. So looking at that, we wrote in our notes that clockwise means to the right and counterclockwise means to the left. So would this be a clockwise or counterclockwise rotation? This is counterclockwise. It's to the left. Yeah. Clockwise to the right, counterclockwise to the left. If you need to draw yourself a little clock, you can, right? You can do the numbers so you can see how it works. Or when you're in my classroom, I have that clock on the wall there. Counterclockwise is going the opposite direction the numbers go. So we are going to try just number one. And then we're going to practice this a lot more in class. Now, what you're going to have to do here is you are going to have to take your paper and you are actually going to be physically rotating your paper. The first thing I want you to do, actually, I think I lied. I think we're going to stop here. I just wanted you to kind of have that basic information. We'll continue with this in class together, I think, because this does get a little bit confusing when you're doing it on your own. I'd rather be with you to work it out a bit better. So I'll see you in class and we'll keep going from